Ozone in the stratosphere. Ozone and oxygen molecules in the stratosphere absorb ultraviolet light from the sun, providing a shield that prevents this radiation from passing to the Earth's surface. Only ozone molecules effectively absorb the most energetic ultraviolet light known as UVC and UVB, which causes biological damage. The protective role of the ozone layer in the upper atmosphere is so vital that scientists believe life on land probably would not have evolved and could not exist today without it. The term shield as a description of ozone in the stratosphere is a bit misleading because the molecules do not form an impermeable sphere around the Earth. Ozone continuously breaks apart into its oxygen atoms and reforms as oxygen molecules, so a particular ozone molecule doesn't last very long. The shield changes constantly. However, the atmospheric chemical processes maintain a dynamic equilibrium that keeps the overall amount of ozone constant. About 90% of the ozone in the Earth's atmosphere lies in the region called the stratosphere, between 16 and 48 kilometers or 10 to 30 miles above the Earth's surface. In the stratosphere, the ozone layer is an important part of the Earth's atmosphere because it acts as a barrier that protects the surface from deadly UV radiation emitted by the sun. When ozone molecules are struck by high-energy UV radiation, it breaks apart and converts the energy into heat. The release of this heat is what causes the temperatures to increase at higher altitudes in the stratosphere. This process prevents the high-energy UV radiation from reaching the surface of the Earth. The individual atoms of oxygen that are split apart by the UV radiation then recombine to form more ozone. The process of destruction and regeneration of ozone molecules in the stratosphere has reached a state of dynamic equilibrium. This means that over time, the amount of ozone gas that is destroyed by UV radiation equals the amount that is reformed. This natural balance has existed in the atmosphere for billions of years. Billions of years ago, before the Earth's atmosphere contained oxygen, there was no ozone layer. This allowed deadly UV radiation to strike the Earth's surface, making it impossible for life to exist on land. UV radiation does not penetrate through water, so during the first 2 billion years of Earth's history, life could only exist in the oceans. Eventually, as the atmosphere became filled with oxygen, the ozone layer began to form, enabling life on land to exist for the first time.